Rio, can't believe I'm saying this. Thank you again for the invite. As Washington said, I'm from the University of Pretoria in South Africa, and I'm a professor in environmental epidemiology, focusing on air pollution and climate change and health effects. So Washington asked me, what do I want to chat about? So I thought we already start talking about the challenges, very similar in South Africa and in Brazil, the challenges to do epidemiology research. So this is just introduction that I will give to you. So here you can see a photo. No, I don't want it to change automatically. I hope it will stop. Okay. Why does it change automatically? Oh, okay.
Yeah.
Yes. Lovely. Let's try again. Otherwise, I have to speak very quickly. That's, which is right. Unless I just do it like this. Yeah.
So right between the two line to the right of the next one. Yeah.
Because that's when it moves automatically. But let me do it like this. I now increase the size of the screen. So I think let's just work with this. So this is the route I drive from home to the School of Health Systems and Public Health, the medical campus in Pretoria. So this is at the Union Buildings in Pretoria. And I took this picture sometime in winter time. So I don't know if you can actually see the air pollution in the picture. It's like this thick layer of air pollution. And it's also due to weather conditions, normally during from April, as we get into winter, autumn and winter, you start seeing this layer of pollution building up. And then people want to know, or I want to know, where's the pollution coming from? What are the levels of the pollution? Because this is definitely not safe levels. If you can see the pollution so clearly, it's definitely not safe. And then if you literally turn your back, how do I? Turn your back, that is the Union Buildings, and a lot of political things happened here. Also, Mandela's funeral was here. All the presidents are inaugurated here. So a lot of things happen at the Union Buildings. So this is actually also where all the laws are ratified and come into effect. And then this is from their household survey in 2019, so already 4 years ago. The latest one, 2021, they did not ask people, do you have a problem with your environmental conditions? And over here, you can see the air, it's the green line. And actually, very few people indicate they have a problem with air pollution. The blue line is mostly waste, because if waste is lying around, you can clearly see that there's a problem with waste. The purple is the land that issue of environmental issues related to soil pollution or land, and then the water is actually lower than the air pollution. So it's actually remarkable that people do not complain more about air pollution, seeing that you can actually see it. But it may also be, it's also an invisible killer. So people have no actually idea of the health effects of air pollution. And as the WHO said, air pollution is an invisible killer. People don't know the health effects that it can have. But then again, I mean, I'm speaking from a lower socioeconomic status position. The vast majority of South Africans live in poverty. They are extremely, extremely poor. So this is, I literally Google photos reminded me the 16th of August, 2 days ago. This was the photos I took a year ago. We went out to Pretoria West in a slum area. Colleagues of mine, they are also doing research in that area, looking at the perceptions of people, how they perceive air pollution, what health effects they have, etc., etc. So we went out to this area, and this is the vast majority of people how they live. You can actually see now all the trash, the garbage lying around, and that's why people said they've got a waste issue, because the municipality doesn't come and pick up the waste. This is supposed to be like a natural lake, but it's literally just surrounded by waste. And the people are living in this informal housing, so they literally survive day by day. So I think their least worry is the air pollution they see. They need to survive on a daily basis. So that might also be an indication why people do not perceive air pollution as a big threat in South Africa. I mean, this is just an indication of our Air Quality Act. The old one of 1965 was replaced in 2005 by the new act. And it actually mentioned air pollution health effects affect the poor. And we also have our constitution to say government is responsible for advancing the betterment of air pollution, of the environment, and let air pollution actually decrease the levels. But that is actually not the case. And then we also have our air quality standards that came into effect 4 years later than the act itself. And they are actually quite lenient, our air quality standards compared to the WHO guidelines. And these ones are supposed to be updated soon, but the government is very secretive of how it will be done. And then the PM 2.5, that only came into effect, the air quality standard in 2012. And at least here you can see progressively the level will go down, but it's not as strict as the WHO air quality guidelines. This is a yearly event that takes place with all the air quality officers and people involved in government and the air quality management in the country. I will also attend this year in October. And they normally present the air quality state report of the country. So here you can just see an overview of where all the air quality monitoring systems are. There is 130 government operated monitoring stations in the country. And then some of it is privately owned. Especially our energy generating company, they also have their own air quality monitoring stations. But these are the most crowded places in the country. The central part of South Africa is literally like a desert. It's very few people living there. So that's why you don't really see a lot of air quality monitoring going on. This one over there, that's where Bloemfontein is. So that's also a big city in the country, but the vast majority of people live in Pretoria, Johannesburg. Durban is over here. Port Elizabeth is London. And then Cape Town is every year. And this was an indication last year of the air quality stations that have actually good data. For the Gauteng province, where Pretoria and Johannesburg is, there is 31 monitoring stations, but only 5 have good air quality data. So that is not a good situation. Even in where Cape Town is, the Western Cape province, 27 stations, but only 4 have good air quality data. And even Washington and I, we had a PhD student, Nandi, and she worked with air quality data as well from the government stations. Lots of gaps, and then she had to use imputation methods to make up for the gaps. So that is actually also a challenge. If you do not know how to do the imputation of air pollution, then you will have to deal with the gaps in the air pollution. So that's one challenge in the country. A lot of people do not have the technical skills, which is actually quite, it's not so difficult to do, to impute air pollution data. But of course, you can't just have 10% of data and now want to impute 90% of the missing data. That's also not gonna work out. So there is a limit how much you can impute air pollution data. So nevertheless, over here you can see very few stations. Of the 132 stations, only 42 nationwide had good quality data. I can't remember what the cutoff value was to be classified as good quality data, but just bear it in mind. And then yet they report data for nearly all the stations. What's the point? I mean, if the data is not good, how can you get an annual average if only 10% of the data is available? So actually, what is the situation of air quality in South Africa? The law says air quality must be improved. But if there's no data to indicate, is it getting worse? Is it improving? How can you say it's actually being improved? And this is for, I'll just show you the PM2.5 and PM10 data. And then I'm sure in Brazil, you also report back to the UN on the Sustainable Development Goals, the progress that you are making. I was actually a co-author for chapter for the SCD 3, dealing with health, me and my colleagues, for the first report. And that was in 2019, we sent it in. I'm not so sure whether there was actually a follow-up report. They're supposed to send to the UN every 2 years, follow-up report on the progress. And over here, you can see the graph, the figure that was reported back on this indicator 11.642. So this is related to the SDG 11, where it talks about urban environment and air quality should be improved. But yet, they do not report how much missing data were actually in getting this graph together. Is all these values based on just 10% of data, 30% of data? We do not know. So how can you actually report this data and you cannot trust what you are reporting? You will also see in 2015, they said the PM10 level is 35 for the countrywide. But if you look at the graph over here, that is 40. So actually, if you were to take an average on these values, I think it's definitely more than 40. It's not even 35. So from 2015 to 2021, the air pollution actually got worse. So that's a challenge we also have, dealing with the government operated data, but how can you trust the data? So that is where my research is coming in. So, and just to let you know, there's also the air quality management plans that's also linked to the Air Quality Act. Every 5 years, all the provinces must update the air quality management plans, and also all the municipalities must update their air quality management plan So an air quality management plan is you look at the current state of the air quality, then you look at all the sources, and then you should identify how it can reduce the air quality. So that's hence an air quality management plan. But if there's no data, how can you know things are getting better? And after 18 years, many municipalities still do not have air quality management plans. So, and most of the provinces have, but only two that's now in the development stage. So that's also where my research is contributing. Where I sample PM2.5, the data can be used by the government as baseline data in their air quality management plan. For instance, I have a student in Bloemfontein at that university. She sampled for a year PM2.5, and that data can actually be used in the first step of setting up an air quality management plan for Bloemfontein. So I try also to do the research that the government can also use in their day-to-day air quality management. So coming back then to this picture, I took this picture, I think it was early July last year. And then I checked on the website, the SACWIS website, the Air Quality Information System website. And for that day, no data available for all the monitoring stations in Pretoria. So then how can you know what the values are? So that's why I started monitoring air pollution on our roof. I don't know if you can clearly see that's at number 1. That's where the medical campus is, where we sample PM2.5 on the roof. And the other 9 stations are operated by the municipality of Pretoria. We call it the city of Tshwane. That's the northern city name for Pretoria. So this is just an aerial overview of the medical campus. That is where my office is, and that's also on the roof where we sample. The hospital is over here, academic hospital. So this is like on a nice hill area. So here is our simple setup where we sample air pollution. It's literally like a clothing drying rack, and we just hang it up. And then you can see here the city. This photo also taken sometime in winter, where you can see the air pollution clearly. And these are the little pumps we used. I mean, this is what some of the filters look like, because we collect the PM2.5 on filter samples. So some we sample every 3rd or 6th day. Nowadays we sample every 6th day. So on this particular day, the air pollution was really bad. You can actually see the filter is quite gray. And then the dates 6 days apart, they were quite clean, the air. And why would that be? It's also because you get rainy conditions. So we even sample it when it's raining. So we just wrap all the pumps in the in equipment in plastic bags, not to electrocute ourselves. So, and of course, when it rains, it washes away the air pollution. So this is an indication of that gray filter. That was sampled in July 2020, and that value was 26.4 micrograms per cubic meter. So it was higher at the WHO guideline of that time. Now the WHO guidelines were updated, so it's actually even more strict. So you can just see that's the pump with the hang up, and here is the cyclone with the filter cassette. And we do this manually. The students come in, they manually take down the pump, change the filter, put it back in a petri dish in a fridge, and then once 10 filters are used up, the clean ones, then we do the weighing of the filters again, just to determine how much PM2.5 we collected on each filter. And this has been going on since 2017 on our roof. And so far, 3 PhDs completed their projects on the data we collected. This is an old instrument we had, like a continuous sampling instrument. This one was replaced in January this year with a much smaller continuous monitoring instrument. So then we can validate our data with the cheaper pumps, with the more expensive online equipment. But with this one, it does not collect air pollution on filters, so we cannot do more chemical analysis. That's why we continue doing sampling on the filters, so we can do chemical analysis also. Here is the photo I took in November 2019 when I went to the University of Gothenburg in Sweden, and I will go again this year in October, November, to analyze the filters for black carbon and organic carbon content. So it's very easy to do, but it's also, it does take time. It's not an automated system. So the current health effect evidence, this report came out with the WHO air quality guidelines in 2022. So it indicates that although air pollution in some countries is coming down, in other countries it's stable, or actually getting worse. And then annually 7 million people are still dying from air pollution. It's a lot of people. And it's also now being recognized as the single most important environmental risk factor. And it's the same as lifestyle, unhealthy lifestyle factors, or smoking even. And then also new non-communicable diseases are also increasing. It's because of the aging population or lifestyle factors that people are more prone to non-communicable diseases. But not in all the countries you've got an aging population. This is for the entire world. You know about population pyramids where you can see what the age structure looks like. This is for the entire world. And this is for Western Europe, where you can clearly see most people are starting to be older than 60 years. And there's fewer young people in Europe. And this is for South Africa and Brazil. There's still a marked difference between the two countries. You actually have a bigger percentage of people who are in their 60s and older compared to South Africa, where most of the people are younger than 60. And it's quite a complicated pyramid for South Africa. I'm sure there are various reasons why it looks like this. Sometimes when you will expect it not to see these different changes in the age groups. So I'm not going to discuss this at the moment. But you can just see in South Africa, we do not have yet so many older people compared even to Brazil. So the current evidence, there's a nice journal article in Environment International where they summarized all the thousands of epidemiology and toxicology results they analyzed in order to come up with the 2021 air quality guidelines. And they basically commissioned 6 reviews. So these are the 2 reviews that dealt with long-term chronic exposure of air pollution. And in most of these studies, most of the studies were done in Europe or the USA or UK, and very few, of course, in developing countries like Latin America or in Africa. In Africa, there's actually no cohort study ever done. So that's also a challenge. There's no cohort studies in Africa to look at the development of disease, how that is linked to air quality, because it may actually be worse in Africa compared to the studies from EU or the US. This was a study on the short-term exposure, or a review on short-term exposure of PM2.5, PM10, NO2, and ozone. And they cited only one study from Africa, and that was my publication of 11 years ago. So it's quite nice to see that the work you do is being implemented or used in studies. And then this was another review on SO2 and all-cause and respiratory mortality. And again, most of the studies are done in developed countries, but of course also some in Latin America. And these were more studies on short-term effects, and it also highlighted not so many studies done in Latin America and very few in Africa. So if you guys want to have an overview of the current status, you can literally just go and download these 6 reviews. That's an indication of the current state of, or the evidence of the health effects of air pollution. And the current evidence increased because of better methods and exposure assessment. And what is telling us, air pollution is causing effects at high levels, but in countries that already has low levels, they still see health effects even at lower levels. That's why the air quality guidelines were reduced, because people could still see air pollution causing health effects at the old 2005 air quality standards guidelines. So more research is needed in middle income countries like South Africa, but of course, like I said, we've got challenges in order to contribute to the evidence. And the WHO made it a priority that more research should be spent, or more funding and research should be done on air quality. And of course, it's now linked to the Sustainable Development Goals. But we're already in 2023. And the Sustainable Development Goals go until 2030. So we have just 7 years left. So I'm not sure how realistic it is to say we will actually achieve these goals, especially when it comes to air quality. But still research gaps remain. And then I will show you the guideline reports. So that's in chapter 8. So this is just to indicate if you want to go and read the gaps, the research gaps, it's all in this guideline report. I will just highlight some of them in the rest of my talk. So more research is needed for the shape of the exposure-response relationship. As I said, most of the studies have been done in Europe, North America, the UK, where the levels are lower compared to perhaps in lower middle income countries where the levels may be much higher. So you cannot just extrapolate that the curve will go on continuously. It may level out off, but we do not know because we need more studies for that. So these are just a few of my articles that contribute at least to the evidence. Whereas most of the studies I've done is done in Cape Town, and the levels are actually similar to Europe or the USA. So it's still at low air pollution levels. It's not high air pollution levels. So it's also in Brazil. I have no idea what your air quality levels are like. If it's similar to Europe, USA, or if it's at higher levels. So that's also something you can contribute to, but I'm sure Washington published articles on air quality as well. in Brazil. But we can discuss this after the talk. And then also look at the toxicity of air pollution. So looking at what is in the air, NO2, PM2.5, NO2, SO2, ozone, but also looking at the chemical species, what is in the PM10, what is in the PM2.5. And link that to health. This was a PhD student of mine, she graded last year, where she did the source apportionment, and then we linked that to hospital admissions in the country. So at least we are starting to contribute to gaps identified. And then a lot of studies, they still use PM10 instead of PM2.5. So these are just a few of my studies. These ones in blue are in highly polluted areas that we've used hospital admission data, whereas this study was done in Pretoria where the air pollution is not so heavily polluted. And of course, the subgroups, all of us, we normally look at the elderly and in women, and the elderly is definitely more at risk from what we've done in South Africa to the risk of air pollution. Also looking at the multi-pollutant exposure and their health effects. So not just looking at individual air pollutants, but what are the mixtures of air pollutants? How can they affect health? And that is what our PhD student Nandi also looked at the exposures, the multiple exposures to air pollution. And also the PM2.5 chemical composition. Again, in this study that we've done on Pretoria, where we manually collected filters for 3 years, analyzed it for chemical composition, and then linked that to the hospital admission data. And some of these chemicals or metals are trace element indicators of biomass sources of pollution, burning fuel indoors, or even trace indicators for traffic. Because of the braking, you can get a lot of metals from traffic. And we also use the data for health risk assessment studies. So this is not epidemiology studies, but it's health risk assessment studies. But at least we are contributing to what the PM2.5 chemical composition, what risks can you expect? And then high and low temperature. Again, this is a challenge. There's only a few monitoring stations for air quality, relative humidity in a city. So how can you say everybody is experiencing the same temperature or relative humidity? Especially if you live in a city like Cape Town, it's a lot of mountains. And if you live in one side of the mountain, it's more windy compared to the other side. So the temperature will feel colder on one side compared to if you are in the city center. So how then can you extrapolate the one temperature site what people experience to the entire the entire city? So that's also a challenge that we need more monitoring stations, even for weather systems. So this is just a few of my studies where we looked at air pollution effects on a low, more medium, and high temperature. And it's not like a linear curve. It's normally if the temperature is low, you get a risk. And then also if it's high, you also get a risk. And then also the challenge is with all these monitoring stations by the government, lack of data. We, as researchers, we will need a lot of funding if we want to replace the government stations with our own research. I don't think that is sustainable, financially sustainable. So there must be other ways one can also obtain air pollution exposure data. This is just a source apportionment we've also done. And then this is a multidisciplinary approach. My research is not on identifying management strategies to lower air quality, but other colleagues, they are doing research on this. This nice review came out, and it actually identified technological mitigation to reduce air pollution, especially in industries, to put in scrubbers or instruments to lower the pollution that comes out from industry. Also, fewer people should use polluting fuels indoors for heating and cooking. But with electricity so expensive, the poor cannot afford electricity. They continue using polluting fuels. So the challenges in South Africa is definitely access to public hospital data. All the studies where I used hospital admission data, it was on private hospital data. And only around 20% of people have medical aid to go to private hospitals. So you cannot really extrapolate the results I get to the entire population. But there's a lack of public hospital data. So what can you do? And then of course the air quality data, like I showed you, all the data gaps. Also access to data, it's extremely laborious process to get your data. So that needs to be streamlined also. And also the lack of skills to use alternative methods. Like I said, if we do get government data, how do you impute the data? Very few people have these skills. So that needs to be improved, to train people, to train students how to do this. And also how to use satellite data, to use it in air pollution modeling. That should be more accessible. More students should be trained how to do this, perhaps in summer schools. And then also to establish cohort studies to follow people up on a long time. But the problem there is it's very difficult to track people down because people move a lot and they literally buy SIM cards every week and they have a new number every week. So it's difficult to find people. So these are the challenges as an environmental epidemiologist working in air pollution, and you are trying to address the research gaps that were reported. So after perhaps 10 years, the next air quality guideline, if they perhaps update it again 10 years from now, I really do not want to see the same research gaps to say Africa, we need more research in Africa, but yeah, things should, I think, try to change, that it's more easy for us to do research in air pollution. So what else can you do? You can look at local sensors. This was a really nice article that was written up by a group of South Africans, where they look at the different local sensors that you can use. My one student, he obtained this Clarity local sensor, even got a little solar panel. And that is after I listened to a talk by someone who the Exitu Environmental Projects company. They sell environmental monitoring equipment. So they agreed to loan us this local sensor. And now my student will use the sensor and compare the results he will get with the filters that he collects. And he's collecting air pollution data in the north of KwaZulu-Natal, in a very rural area. So it will be quite nice after a year to see how the local sensor, the data compares to our filter samples. This is also an option, the Purple Air monitor. It's not that expensive. And so this is also something that we are looking at to perhaps just get one on our roof and to start comparing it to our filter samples and also our online monitoring, just to validate it. And then, of course, there's a lot of air quality modeling you can do. This is a very nice review. But as I said, there's a lack of training, especially for people in public health, students in public health, to train them how to use satellite data, how to do land use regression modeling, and if the data is even available, if you want to do land use regression modeling. So that's a challenge in the country also. Another option would be to use deep learning. It's a subset of artificial intelligence to predict air pollution data. And I am the co-supervisor of a student from the University of Venda. So Roranzu, she's the PhD student, and Wilson Gitari is the main supervisor. So she submitted this publication, how to do deep learning methods to predict air pollution in the Langa-Highveld area. It's a very polluted area. So that's an option to go as well. But very few people have these skills, these data science skills, even us as supervisors. And the students do not get training how to do data science. So that's a gap that needs to be actually identified in the curricula, that more students should be introduced to data science, how to do, run these algorithms in themselves. So that is my talk. We have so many languages in South Africa, so that's how you say thank you. Thank you.
Algum comentário, alguma pergunta?
Washington will be a translator. Yeah. You can ask in Portuguese, and Washington will be a translator.
Sim. Uma curiosidade. Yeah.
You said one thing that is a challenge here. Monitoring from governmental agencies that could be linked with university research. And this is probably something that is a challenge for us as well. We have agencies, policy, safety, everything. So you could make a comment of that. Maybe this challenge is in dealing with this
Actually, it's the same thing. We have large cities, few monitors, gaps in data. She described our reality as well. So,
At least in South Africa nowadays, I think it's for the past 3 or 4 years, you do not need to request air pollution data anymore. You can just download it yourself. And that is amazing. That you don't have to wait to get data. You can download hourly data or 24-hour average data. We normally download our hourly data. And then we calculate a daily average must be based on at least 18 hourly data. Otherwise, it's set as missing. If you just download 24-hour data, you don't know on what is it based. On 1 hourly data, I mean, it doesn't make sense. So that helped us a lot. Now that the data is available online, we can just download it yourself. But the hospital admission data, that is still a challenge. You first, of course, all our studies, we need ethical clearance first. So even the study on the roof, even if it's just doing air pollution sampling, you need ethics clearance. And then before hospital data will be released to you, you need to submit your entire proposal ethics clearance to the hospital group before they will release the data. Yeah.
Yeah, but we have those online, mortality, hospital admissions, even this primary care data. We have, yeah. we have
Yeah,
all
so
those on-
in that respect, you have the benefit that
both data. Actually,
When you start, we do have a lot of data, although, well, it's going to record is too early. But, yeah.
if you want individual data, yes, you have
Yeah.
to ask for the data. There is all this process, but most of the time we use anonymous data, so not a problem.
yeah, and we normally get count data, so daily count data, which is fine. Mhm. Mhm.
Or generally, more so renewable sources like hydroelectric.
Mhm.
How do you make all that? How do you
That's a good question. Yeah, all our energy is coming from coal still. So literally at that industrial scale, you will have to introduce technology to minimize the emissions of the pollution coming out, but that is quite expensive. And the power stations are also extremely old, so sometimes you can't fit the new technology in these old power stations. So it's definitely a lot of particulate matter, CO2 coming from coal fire stations. Then you have, like I said, the poor cannot afford electricity. So then they still use wood, coal for indoor space heating in winter or for cooking in all year round. So that is the mix you see in the country. And if you download hourly data and you plot there by hour of the day, you can literally see there's like two big peaks. And especially if you look then at summer and winter, the peaks in winter time will be much bigger in the morning, and then it flattens off a bit, or it will remain more stagnant because of the weather conditions, depending where you are in the country. And then it will go up again in the evening when people are coming home and cooking. Now that these two peaks can also overlap with the traffic in the morning and the traffic in the evening. So definitely the air pollution coming from the energy mix is completely different, I would say, than in Brazil, where you use more renewable energy. So even your own data, if you were to get hourly data and you plot it, you will literally see a peak morning air pollution, and then it normally plateaus off, and then you see a peak in the afternoon again. And if you do that on weekdays and weekends, you will also see a different peak. Perhaps that peak will shift on weekends because people sleep a bit later, and then traffic picks up again. And it also depends on the weather conditions. In Cape Town, it's a winter rainfall season. So then, although people will use indoor fuel, and it, of course, it goes into the outdoor environment, it may get washed off. So the level may look down, may look low because of the windy conditions or rain conditions. So South Africa is a very complex climate system as well. We've got tropical climate, Mediterranean climate, savanna climate, and different winter and summer rainfall areas. Not really in the hospital admission data that I use, because that's more the higher social. But again, you must remember, a lot of people, when they start working, then suddenly they get medical insurance, because I don't pay all my medical aid for myself. I pay 50-50. So the work pays, start paying your medical insurance. So a lot of people, they may have grown up in poverty. And then suddenly when they are 20, 21, or 30, when they start working, now they get a medical aid. So it's not that they started off in a higher socioeconomic status. So one can't actually compare even my hospital admission studies to that of Europe, because not everybody started off in a higher socioeconomic status. So it's more complex. We did do cross-sectional studies where you have schools in one area and another area. And if I'm not mistaken, normally people in the lower poorer areas, because of the air pollution exposure, their health effects, the asthma, eczema, is worse than kids going to schools in other areas where they don't use indoor air. It's quite interesting to, when you see these results.
I have some studies here, mostly using those daily counts, aggregated data. Daily counts, time series studies, that stratified by some kind of socioeconomic index, and EAS. You see that the effect is higher on the lower level of socioeconomic status. It makes sense. Rich people go elsewhere. Araras, for instance. It's quite clean. Yeah, and you have the it's a multidimensional issue, because poor people have less access to health. So it's not a simple, when we only stratified by socioeconomic status, we actually are oversimplifying the approach, because so yes, when we stratified, we see that poor people are more has higher effects of air pollution, because they live in more polluted areas. They have less access to health, on top of other limitations that lower socioeconomic people submit to.
It's also interesting, because I think higher socioeconomic people also tend to go on holiday, and then they may move away from a highly polluted area to a less polluted area. And so their yearly pollution dose is actually lower compared to people staying in that pollution hotspot all the time. And then it's also about weather conditions. If people are staying in cold weather, which is not good for your health, too hot weather, which is not good for your health. But if you can afford to go to a cooler place and cleaner air, it's good for your health.
The question that you have a table showing the composition. Maybe I don't know, it would be interesting to apply to that change. What I'm hoping is change the source of energy with the time. Most of the African have an issue with the some of the problems and others to reduce but it's also change. So this is the type of analysis that they give stuff of I don't know, contribution, knowledge for the quality discussion, for the agenda for training in energy. This type of discussion may be very compared compared to look at the trend in most stuff. That's what they do.
And it will actually be like a national experiment when the country is moving over to renewable energy compared to when it was still using coal.
Almost like
Exactly.
experimental analysis. But let's get to it. Two different. Brazil was different to this. You know, there's analysis to compare the 1940s, Brazil was in the Kenya today. It's quite like to put to the table to transform. But to look longer, indicate before the change completely. Now the river, the air, the climate, that's why we're going to take care of the whole, I think this is I'm coming from the policy perspective, then now, the local do this cohort for the same time. I don't know the big point. But the policy is that they need to
I have finished. I have a question. It's more like a provocation, actually. Car manufacturers in developed countries, mostly US and Europe, are selling the idea that electrical vehicles will save us because of the tailpipe zero emission. How do you see it working in developing countries like Brazil and South Africa, even considering all this power generation limitation that we already have today? So how you see this electrical car? It's been very welcome here in Brazil, this idea of saving the planet by using electrical vehicles. I would like to hear your thoughts on that.
Yeah, I think definitely, I think in South Africa, we will need clarity. Who will pay for the electricity and where will you get the electricity? Which at the moment, I'm not sure if it's free. If you buy a car, you can just go and plug in. Because at the moment, if you want to charge at your home, it's not going to work because we have a lot of power outages nowadays. So personally, with all the power outages, I would not buy an electric car at the moment. Because we do not know what's going on. It's not clear, communicated to the public, if electric cars are coming in, where would you plug in your car? Would you have to plug it in at your own home? But if you have electrical outages, so how will that now, how will you actually be able to drive off if you don't have electricity to charge the car? So, yeah, would say it's, from a practical point of view, it's not practical at the moment.
Walk around with long and think about, walk, you have 2 or 3
Oh,
places, but I don't know what to practice. And the cables coming from house.
so even in Brazil, I do not see a lot of cars plugged in.
Yeah, there are a few,
Okay.
some kind of being pushed through off roads because I don't think we are ready for this. I fail to see mainly big cities like and central parts of these big cities like São Paulo and Rio, South area, downtown, you have those poles to charge your car. I don't see it happen. Maybe Santa Cruz, Campo Grande, or on the outskirts of Rio de Janeiro, for instance. I can't tell them poles, it's outlets you can park and charge your car.
You
I
understand?
don't see it happening.
Now, you can just go and park and charge the car.
I just what you don't have to do a few that
Yes.
Yeah.
And
you have to plug your house. So maybe some Paulo have to.
also our power grid is working on limits as well.
So it's,
So you
it's,
don't have
it's at the near the maximum in Brazil as well.
Yes.
It's not that you have a lot of electricity that you can export to other countries.
Yeah, especially for you to expand that.
you don't have any electrical unit to power to spare.
So then as well, if suddenly 2 million people are gonna plug in to charge the cars.
No, well, yeah. Global, like, people have a complaint. So well, you need to back the success, they start to complain about the price of what they're paying. And some people are trying to change back. Sell the price that they want with some incentives now. They want to too expensive to keep.
There is also another issue because
The battery is not the issue.
yeah, aside the batteries, actually what electric cars do is to move the tailpipe emission from the user who actually use the car to someplace else, because in order to have more electrical power, we have to install this thermal. Mainly here in Brazil, we have nowadays lots of new thermal electric power plants being built. So you are moving air pollution from cities to elsewhere. So people who didn't have, who weren't exposed to air pollution before, they will be exposed now because they have this natural gas powered power plant in their backyard. So I think we have to think this through before embrace this idea of cars you save, electrical cars you save.
The car is a main source of pollution. So, yeah.
Less inventory from our state environmental agency said it's a bit old, but I don't think it's very different now. 70% of our emission is from tailpipes. So from vehicles. I don't think it has changed.
Yeah.
Right there, you know, old data, in the class, I might have thought that we, whether more clean, on electrical cars, all that,
Yeah, because of the primary, it's still coal based. Yeah, so you'll actually pollute more in order to fund your cleaner car. Yeah.
Compared to new cars, yeah.
Mm, 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 yeah. Yeah. Yeah, so I think that's what people call lifestyle life cycle assessment. You have to look at the entire life cycle of where it's coming from, even to make that car, how much pollution is caused, environmental degradation, the people then using it, and also when people are old cars, what will happen to the old cars, what will happen to the old batteries. So it's a whole life cycle assessment. I did not look for a journal article. I don't know if anything is out there. Perhaps there is something out there that people commented on moving from petrol or diesel cars to electrical cars or even hybrid cars. Or it could be a master's project. Someone can just do a literature review.
No one else? Claudia? Okay. Cyprus. Okay. That's Janine. Once again, thank you for coming, share your research with us.